Hey there, I hope I'm audible to all of you. Alright, welcome back to this amazing platform of Pradhan Academy. And today we are live again with another important topic, and that's gonna be on probability. Right. So we are going to get started for the upcoming JEE Advanced examination, and our topic is going to be probability. Right. So I know that tomorrow you're gonna have your JEE Advanced, right? So I hope you are ready for that. Do let me know in the live chat. Alright, so keeping all those things in mind, I'm here again back with this important topic, and today we're going to discuss probability, because probability I think is an easy chapter, though it might not be seeming easy for many people, but it's very interesting to think about and discuss the cases in general. Okay, so if you look at probability in general or overall, I would say it's easy as well as it's very interesting. Okay, so that's why I'm taking this up a day before the exam. I know this is going to be very important day for all of you, right? Before the day before the exam. And I just want all of you to be relaxed a bit and don't stress out much because of the exam tomorrow. Okay. So I want all of you to be chill a bit, and along with that you're gonna also practice and understand the concepts that is very required or very important for the coming exam. Okay, so keeping all those things in mind, let's get started. So today I'm going to discuss about the probability. So before you start, it's very important to have a good understanding on these concepts. So for that I would suggest you to make short notes. Okay, to make short notes, and then you can directly jump on to having and discussing the questions of JEE Advanced with me. Alright, so in this session we are going to discuss about the concepts, and along with the concepts we are also going to discuss some of the important questions as well, right? So it's a very good idea, if you have prepared your short notes, just quickly grab through over it, okay, and just quickly revise with your short notes. This is going to help you a lot. All right, so with this part, let's get started. And there is a very important announcement for all of you, that we are going to start the live batches for the upcoming sessions, and especially for someone who is currently in class 11th or currently in class 12th, and they're starting the preparation. It's a very important opportunity for all of you, that we are coming up with live online batches, and the monthly fees is starting just at rupees 999. Okay, so in case you want to get information about the upcoming batches and all, you can always contact on this particular number that is mentioned over here. All right, and in case you want to get more information about the batch related informations and many more stuffs like that, you can always join our Telegram channel. The link is in the description. All right, so you can find the link to the Telegram channel in the description box. Okay, do join our Telegram channel in order to not miss out any upcoming notifications or contents related information. All right, so with this information, let's get started on today's goal and today's important topic of probability. Okay, so I hope this is all clear, and we are all ready to start with the topic of probability. Right, so today our goal is to discuss the previous year questions of probability, and we are going to practice both MCQ and numerical type questions, and in general we are going to solve the previous year questions. Okay, so with this part, let's start. Now before we start with the probability, two of the most important theorems or the results of probability that is very important for the upcoming exam, those are the first one, starting with the total probability theorem. Okay, so this is the first theorem, that's the total probability theorem. So it's a very important theorem in case you want to deal about probability. In general, most of the questions are going to be either of these two. Okay, so what the total probability theorem talks about is that if you have a sample space, let's say the sample space set is given as S, and let's say the events E1, E2 and so on up to En are the n mutually exclusive and exhaustive events. This is very important to understand, that these all events are mutually exclusive and exhaustive. I hope you know what's the meaning of these two words, right? Mutually exclusive and exhaustive, because that's very important to understand, and also have an understanding that there are nothing apart from these events that comprises the entire sample space. right? So all these events that you can see over here are the entire sample space, right? So these are the events that are associated with the random experiment that you're performing. And let's say A is basically an event which is basically occur with some with E1, some with E2, E3, and so on with En. And then if we are interested in finding out what's the probability of occurrence of that event, then it is very simple. We just try to find out what is the occurrence of this event E1, and then we try to find out what is the intersection or what is the common region of occurrence of that event A with reference to the event E1, right? So that is very, very important to understand, and we basically try to sum up all the possible cases, and then we get the result over here. Okay, so that is quite important to understand, because this is going to be very, very important. Okay, and once you are done with the total probability theorem, Bayes theorem is nothing but it's just like an inverse of a total probability theorem. Let's say a particular event that you're trying to figure out what's the probability of that occurrence of the event. Let's say that event has already occurred. Then what is the probability that that particular event has occurred, given that it has occurred by that particular following path, or maybe by following condition of the event? Okay, so it's just like an inverse of probability. Okay, so it's like inverse. I would say it's kind of an inverse. Oh, sorry for the bad handwriting though. Inverse of total probability theorem. Okay. Okay, so it's just an inverse of total probability theorem. So it basically talks about that if an event A has already occurred, and we have a lot of different events like E1, E2, and so on, like ENs. So the summation on the union of all EIs are basically the sample space S, and then you have to find out that that particular event has occurred or as due to this occurrence of this event EI. Right, so then we basically try to figure out this conditional probability, that is probability of occurrence of EI, given that A has already occurred. So this can be simply given out by this particular form over here. So it's just by using the the conditional theorem, conditional probability, and we are trying to represent the probability over here in the following manner. I hope this particular part is clear to all of you, right? Because these are the most important theorem that we are going to use up interchangeably in our questions. Okay, so with this part, let's get started on doing solving the questions. Okay, so here we go, solving the first question. Okay, so it says that there is a bag with us. Okay, there is a bag, and this bag consists of n number of balls. Out of this n number of balls, let's say, let me try to draw the figure as well. So let's say there is a bag which consists of n balls. Okay, there are n balls, right? And out of these three balls, right? Three balls are white, and we have six balls which are green, six green balls, and the remaining balls are all blue. Okay, so that is n minus 9, which are blue balls. Assume that the balls are identical, otherwise three balls are drawn random one after the other without replacement. Now this kinds of word is very, very important while you're reading the question. Okay, without replacement. Okay, that is very, very important. So you're not replacing the ball. So as you are doing the first as you're drawing the first ball, the number of balls is decreasing in the bag. So you have to keep a track over that as well, right? So it's very, very important, once you solve the questions, it's very important to read the question and try to understand what the question is trying to figure out, right? Sometimes it is not mentioned, especially that the replacement is done or not. So it's very important to read the question properly and then start to solve the question. Okay, because depending upon the question, this cases will vary each the time. Okay, now it says that for I equals 1, 2, or 3, let's say the Wi, G of I, and B of I denotes the events that the ball drawn in the ith draw is a white ball, green ball, and blue ball. Okay, so the I denotes the draw, the which draw is it? Okay, so it's the first draw, second draw, or third draw, because you're drawing three balls, right? Now it says that the probability the probability of getting the first ball as a white ball, and then getting a green ball on the second draw, and then getting a blue ball on the third row, that's given as 2 upon 5n, 2 upon 5n. And the conditional probability that a blue ball occurs on the third row such that white ball and green ball has already occurred on the first and the second respectively, that probability is given as 2 upon 9. So if we have this information, we have to find out what's the value of n going to be. Right. So it's a very simple problem. Just try to understand how we have to solve this problem. Right. So let's say I try to figure out that this particular conditional probability is given to us. Right. So if I quickly recap what is conditional probability. So if I have two events and the conditional probability of A, given that B has already occurred, it is simply by the probability of A intersecting B divided by probability of B. Right. So that is basically the conditional probability. That's defined as the conditional probability. Right. So if I just apply the same principle, same formula over here, this is going to be probability of B3 intersecting W1 intersecting G2, right? So that's the probability divided by the probability that I get white ball on the first row and the green ball on the second row, and this is basically given as 2 upon 9. Now we all know this particular probability over here, so if I just try to simplify the algebra over here, so it's basically 2 upon 5n whole divided by the probability of getting a white ball on first row and green ball on the second row, and that is given as 2 upon 9. Now I have to figure out what is this particular probability over here, right? So if I try to understand getting a white ball and then getting a green ball on my second row, I can do it in the following way. So this is basically equals to, so if I have to get a white ball on my first row, then out of the 3 white balls, because I have 3 white balls, so out of the 3 white balls, I have to draw one, right? So that is basically given as 3 upon n. And then now since these events are basically mutually exclusive out of them, so, or I should say these are independent events, so it doesn't depend whether I'm drawing a green ball or this white ball on my first or second draw, right? So getting a green ball on my second draw such that already a white ball has been done, that basically is counted as a ball has already been drawn from there. So I have 6 green balls and the number of balls now in this case is n minus 1. That is very, very important. Okay, so this is very, very important. I'm start marking it over here, right? So this is what you will get as a probability, right? Now if I just plug in this information into this equation, I'm going to get the result as follows, and that is going to come out as 2 upon 9. So this is going to be, so from here you're going to get the most of the information, right? So from here you will get n minus 1 equals 10, and that basically gives you n is equals to 11. So very simple, straightforward problem. Just carry out these calculations step by step and you're going to get the result very easy, right? The question might look bit of a confusing in the beginning, but if you just read the questions properly, and this is going to make sense a lot. Okay, so the answer to this question is going to be just 11. I hope you are getting it. Just let me know in case you have any questions. Hi ones, I got the answer before you. Wonderful ones, one study, that's great. If you are getting the answer before me, that's excellent. I got the answer before you. Yes ones, that's excellent, that's excellent. Okay, so you got the answer is 11. That is excellent. Okay, easy. Yeah, it's very easy question. It's a very easy question. Okay, so I hope we are all in the same track. Yes, easy, easy, easy. Correct, correct. So let's move to the next problem then. All right, so there we go. Okay, so the next question is on your screen. Just give a read, right? So the next question is on your screen. Just give a read and try to think how you can solve this question over here, right? So it's a question on binomial distributions. Okay, so let's see what the question is talking about. So it's about probability distribution, and it says that the x is a random variable, and it says that we have the probability of x equals small x is the probability of the random variable taking a value x, right? Let's suppose the points x comma p of x equals to x are the points that are fixed on the straight line in xy plain. And then it says that the probability of x equals to x is equals to 0 for all x belongs to real number minus these values of integers 0, 1, 2 and 3 and 4, right? And then it says that the mean of, then if you find the mean of, so I'm writing expected value of x, that is given as 5 upon 2, and the variance of x, okay, so variance of x is given as alpha. So we have to basically find out what's the value of 24 times alpha. All right. So let's see what are you getting as answer. So please try this question. Please try to solve this question over here. This is a very straightforward problem. Not an issue for any one of you, I believe so. Right. So x belongs to all the real numbers, but the probability of x equals to x is equals 0. The probability is 0 for x belongs to all real number except those integer points like 0, 1, 2, 3 and 4. Okay, so if you consider this following points as integer points, you're going to get, except them, you're going to get the answer or the probability as equals to 0. I'm not able to understand. Why once you're not able to understand? Please let me know why you're not able to understand once. Please let me know which part you're not able to understand. I hope the question is clear, right? Okay, so let me show you how you can proceed with this question. Okay, so the question is very straightforward. Okay, let's try to make a table over here because it says that all the probability for x and probability of x, they are basically on a fixed straight line. Okay, so let's say that let the equation of the line b equals to mx plus c. Let's say that the equation of the line b equals to mx plus c, and then let us try to plot the probability distribution table. And if I put x equals 0, the value is equal to c. If I put x equals to 1, the value is m plus c. If I put 2, the value is 2m plus c. If I put 3, the value is 3m plus c. And then if I put 4, the value is 4m plus c, right? And except all the other places, we will have the value as equals to 0. Now we all know that the summation of probability for all the events is basically equals to 1, right? So if I just apply the same thing over here, I'm going to get a one equation, and that is basically like, so we have total 5c, and then m, if I take m in common, 1 plus 2, 3, 3 plus 3, 6, and 6, that is going to be 10m is equals to 1. So that will give you 2 times of m plus c is equals to 1 upon 5. That's a one equation that you're going to get. Okay, so that is one of the equation that you're going to get it over here. Now the next thing that you're going to figure it out from here is that you have to find it out the value of m and c. So one of the equation you got it from here, right? The next equation you're going to get it from the expectation or the mean. Okay, so mean is basically summation of xi into p of xi. Okay, so if you just do the summation over here for xi and p of xi, it is going to be like m of xi plus c into xi. Okay, and then sum of it, and that value is basically given out as 5 upon 2, and that value is given out as 5 upon 2, right? So if I solve this part again, I'm going to get one more equation, and that is going to look like 30m plus 10c, that is equals to 5 upon 2. Okay, and this is going to be equals to 3m plus c is equals to 1 upon 4. 3m plus c is equals to 1 upon 4. Let us say this is the second equation. So first equation over here, and we get one more equation and this. So if we solve this both equations, so if I solve 1 and 2, I will get m is equals to, so I will get m equals to 1 upon 20 and c is equals to 1 upon 10. So if I just try to solve these two equations, I'm going to get the value of m and c as well. Once I get them, then I know what's the probability. Okay, so I know the probability now. So in this case, getting the variance is very simple. So variance of x is very simple. We just need to find out the variance of x as probability of pi xi square pi minus summation of pi xi whole square. Okay, so that is what you have to do in order to get the variance, right? So if I do the same thing over here, we just take the summation of, so this is basically mxi plus c and then xi square and then sum over it minus, this is nothing but the expectation values. So this is going to be minus of 5 upon 2 whole square. Now if I put in these values of m and c into this equation over here, this value is going to turn out as, this value is going to definitely turn out as, so that is going to be like 100m plus 30c minus 25 upon 4. Right, now if you put in back these values, and therefore the variance that is given as alpha, you're going to get the variance as, it's very simple, you just get the variance value over here as very simple, right? So the variance will turn out to be, okay, so here from this value the variance is going to be, yes, 7 upon 4, correct. So that is going to be equals to 7 upon 4. Are you all getting the variance is 7 upon 4? So from this, if I need to find out what is 24 times of alpha, this is going to be equals to 42. This is going to be equals to 42. Okay. So therefore, the correct answer to this particular problem, or the numeric answer to this problem, is going to be equals to 42. Are you all getting the same answer? Please let me know if you are getting the same answer or not. All right. Is this part clear to all of you? Is this part clear? Please let me know if this part is clear or not. Okay. So if this part is not clear, please let me know. I will try my best to explain you again. Okay. I hope this part is visible to all of you, right? Just check. Please let me know in the live chat if anything is not clear. I shall try to repeat it again. Okay. So I will write it over here for you. This is basically 1 upon 5. Okay. This is 1 upon 5. Right. This is 1 upon 5. That's what I've written over here. So I hope now you can see it, right? Please let me know in case you have any questions. I will very happily answer your questions. Okay. Don't keep your doubts in your mind. Avoid doing that. It's very important to get your doubts cleared. Otherwise, you're going to have a hard time in the exam hall. All right. Is this part clear to all of you? Okay. So with this, let's go to the next problem. The next problem is a very interesting problem. Now it's all about a set of 5-digit numbers, and the following digits are given as follows, right? So we have 3 2s and 2 4s, right? Now it says that, for example, 22240 is in X, while 02244 is not in X, because that makes sense, right? It's not a 5-digit number. And 44422 is also not in X, because there are now 3 4s, right? It's very simple. Now let's say that suppose each elements of X has equal chances. Suppose the elements in X has equal chances of being chosen up, And let's say that the P denotes the conditional probability that an element chosen at random is a multiple of 20, given that it is a multiple of 5. So you have to find it out what's the value of 38 times P. Very interesting problem. Very much interesting problem. Let's see how we can try to proceed this problem over here. First and foremost, don't stress out at the beginning seeing the problem, that is going to be a very difficult problem, right? First and foremost, be normal. Okay, whenever this kind of problem will come up in your examination, I'm trying to tell you how should your thought process be all about. Okay, be normal. Think of how can you form the 5-digit number. First and foremost thing, let's try to understand how we will proceed with this question over here, right? So in order to start with the question, it's very important. Let's say that these are the 5 digits of a particular number. Then if I need to this number, let's say x to be a multiple, for x to be multiple of 5, the last digit should either be 5 or zeros. The digits that are possible, if in order to be a multiple of 5, the last digit should be 5 or 0, right? So if I fix in 0 as a last digit, and then I keep on changing or permuting all the digits in the 4 places, then so let's say the digits can be 1, 2 or 4, right? And we have 3 2s and 2 4s, right? That is very important to be specific. So let's say I take the case when I just only use the digits 1 and the 3 2s. Okay, so 1 2 2, right? So in this case I will have total of 4 factorial upon 3 factorial k's. Similarly, if I just take in this 4 places and the last place is 0 is fixed, and then I take the 1 2 2 and 4, then also I will have 4 factorial upon 2 factorial ways. And similarly, these 4 places I can fill this 4 places with 4 2 2 and 2. Then also I will have 4 factorial upon 3 factorial. And then I can also do one more way, is that these 4 places I can fill with 2 2 and 4 4. That is basically like 4 factorial upon 2 factorial upon 2 factorial, right? And also one more case is left, is that we can take these 4 digits and the 0 is fixed, and we can keep these numbers as 1 2 and 4 and 4. So that basically gives you another 4 factorial upon 2 factorial, right? So this is all the multiples of 5, because what I can do, I can count the total number of elements, total number of numbers which are ending with zeros, and similarly the case goes for the number of elements that is ending with 5, but there is no 5, so that doesn't count. So we have these are the number of elements that is basically multiple of 5, so that basically rounds up. If we count it up, it's going to be equal to 38, right? Now if an element is a multiple of 20, if an element is a multiple of 20, the important thing is that it should also be divisible by 4, right? So in order to be divisible by 4, the last 2 digit should be divisible by 2. So if I say that among the 38 elements, let us calculate those elements which are not divisible by 20. So if I need to calculate the number of elements, so in this x, so from these 38 elements, if I counted the elements not divisible by 20, then these are going to be, so I'm just having the last digit as fixed as 1 0. So in that case I will have the 3 digits to figure out, either it can be 2 2 2, or it will be like 2 2 and 4, or it will be like 2 4 4, right? So all these cases, and if you just count it up, it's going to round up and come out as equals to, so for the first trace it will be 3 factorial upon 3 factorial, it's going to be 3 factorial upon 2 factorial and 3 factorial upon 2 factorial. So all this will cases and come out as equals to 7. So there are 7 numbers which are not divisible by 20. Apart from all 7 numbers, all the other elements in these 38 elements are divisible by 20. So that basically gives your probability, that your probability P to be divisible by 20 and divisible by 5, those are basically equal to 38 minus 7 divided by 38, and that is going to give you as 31 upon 38. So 38 times of P is going to be equal to 31. So that's the pretty simple answer to this particular problem over here. I hope you are able to get the same answer as of mine. Please let me know in case you have any question. Is this part clear to all of you? Is this part clear to all of you? Please let me know if you have any questions in your mind. Right. So this is not a very difficult problem, but again, in case any difficult problem comes up for your GE Advanced, what is the most important treatment is that it's very, very important to understand the question first of all. For that, read the question carefully, go through the question again and again. In case the question doesn't make sense, you will have to go through and read the question again and again. It's very, very important to read the question properly, and once you're able to understand the question, it's very important to also figure out how you are going to step by step proceed it. Okay, in case any difficult question comes up, it's very, very important to have a step by step approach to all the question. Okay, now if you just break the bigger problem into smaller parts such that you are doing the smaller parts one after the other, then the question will be very simple. So please try to follow this approach whenever you are dealing with any difficult questions. Okay, so it's very, very important that whenever you're dealing with difficult questions, try to break the question into smaller steps, and once you break the question into smaller steps, the question will seem very simple. Okay, so make sure you do that, and if you do that, everything will be very, very easy. Okay, so with this, I would say that don't stress out much for the upcoming J Advance. Keep all the basic things in your mind, and if you're good with the basics, everything is going to be shot out by itself. Okay, in case the paper comes difficult, don't worry. Okay, everything will figure out. Okay, so if the paper is difficult, the cutoff will go low. If the paper is easy, then the cutoff will go high. So always pray for difficult paper, I would say, in general. Okay, so if the paper is difficult, it's easy for you to get a good rank, and I mean, not a good rank, I would say getting selected into IITs. Okay, all right, so that's pretty much of it for today. Right, so we are also going to discuss some of the important strategies regarding how should you prepare for your exam, or what are the last minute strategies. And for that, stay tuned on this particular channel. We are going to come with a video on discussing what are the last minute tips and what are the strategies, what should be the paper attending manner you should attend the paper, all these things that we are going to discuss in a coming video. Okay, so stay tuned for that, and all the best for the upcoming J Advanced exam tomorrow. So with this said in mind, I would try to take a leave from this video, and thank you for your attention.